Hello. In this video, we'll talk about how to access database in a Spring Boot application using something called Spring Data JPA, which is actually two things, Spring Data and JPA. But anyways, let's get started. We said in the previous lecture that virtually all database systems use the client-server architecture, and our applications are a type of client. In order for our application to connect to the server and access the data, we'll need a library. This library will send SQL and other commands from our application to the server and get the results from the server back to our application. In Java, this library is called Java Database Connectivity, or JDBC. This library actually consists of two parts. One part defines the API of the library, and this part is included in the standard Java libraries. The other part is called JDBC driver, which implements the JDBC API for a particular database system. This part is usually provided by the database system vendor. So, for example, if we want to use MySQL, we'll need to download the MySQL JDBC driver, either from the mysql.com website or let Maven download it for us as a project dependency. So here's an example showing what JDBC code looks like. So for example, suppose we want to load a bunch of employee records from a database. So we'll do a SQL query like select star from employees, assuming we have an employees table containing the employee information. Using JDBC, we'll need to first create a connection, then create a statement, and then pass the SQL query as a string to the execute query method, and the underlying JDBC library will send this SQL query to the database and get the results back and store the results in a result set. Our application code doesn't deal with result set directly. Instead, we'll need to create a list of employee objects, and then we iterate through the result set, and for each result row, we get the ID, first name, last name, supervisor ID, and we use that to create a new employee object and then add to our list of employees. So that's basically how JDBC works. Now, there are some problems with JDBC. The biggest problem, in my opinion, is the mismatch between object-oriented class design and the relational design of tables and columns. Let me explain this with a quick example. So suppose I want to have an employee class. An employee would have ID, have a name, and have a, let's say, supervisor. Now, a supervisor is another employee, and so naturally, in a good object-oriented design, we would have something like this with ID and name, and then an employee field which has a supervisor. The problem with this is that we cannot match this directly to a table design. Now, in a relational database table, the employees table would look like this. It will have integer ID, it will have a varchar name. However, there's no employee type in SQL. So instead, we'll have to use a supervisor ID column to represent the supervisor. Now, as we can see here, now we have a mismatch between the supervisor field in the application code and the supervisor field in the database. Now, using JDBC, there's no easy way to reconcile these two. So if we use JDBC, then most likely we'll change our class design, and instead of saying employee supervisor is an employee, we change this to supervisor ID, so that this one can match with the database column, so that we can easily create an employee object based on what's stored in the database. Now, this is what I mean by a mismatch between object-oriented class design and the relational schema. And in 99% of the time, if we use JDBC, we end up changing our class design to fit the relational table design. Or in other words, because we have to store our data in a relational database, it kind of limits our object-oriented design and forces us to create classes that look like tables. And that, in my opinion, is a big problem. A secondary problem is the tedious code needed to convert between objects and properties in application code and rows and columns in application tables. This can be seen easily here. We get data from databases as rows and columns, and then we have to manually convert them into objects. And same thing when we try to save an object. Instead of just saying save object, we'll have to break the object down into individual fields and then combine them into an insert statement or update statement. Here, there are only 4 fields, so it's not too big a deal, but for a complex class, we can easily have 20, 30 fields, and that becomes very, very tedious. And the last and somewhat minor problem is having potentially database system-specific SQL in our application code. Here, for example, suppose we want to concatenate the first name and last name of employees. Our SQL code could look like concat first name and then space and last name from employees, something like this. The problem is that concat is a MySQL function. If we need to switch to a different database system, we'll have to change many of this type of SQL queries in our application, which are specific to MySQL. And that's something we'd rather avoid. So is there a better way? The answer is, of course, yes, and it's called Object Relational Mapping, or ORM. ORM library sits between the application code and the relational database. It automatically converts the objects and properties in the application code to rows and columns in the database, and vice versa. It basically allows application to deal with objects without having to worry about how the objects are stored. There are different ORM solutions for different programming languages. For example, if you use Python, you'll probably use SQL Alchemy for ORM. If you use C#, you'll probably use Entity Framework Core. For Java, the ORM solution is once again split into 2 parts, API part and implementation part. The API part is called Java Persistence API, or JPA. The JPA standard defines a number of annotations that are used to map classes to tables. It also defines a data access API and object-oriented query language called JPQL, or Java Persistence Query Language. There are several popular JPA implementations, and the most commonly used one is called Hibernate. When we use JPA in a Spring Boot application, by default, it will use the Hibernate implementation. Now, let's do an example to make all this more concrete. We'll work on the guestbook example from the Spring MVC lecture, and the goal is to basically use a database to store the guestbook entries instead of storing them in memory. Now, first, let me run this application, just make sure it still works. Okay, so we have the guest book here. If we add comment, I have to enter something. Let's say Tom says hi, and we have it here. So it works. And in the current implementation, the data comes from the data store bin, which keeps a list of guestbook entries. So it's not using database. Okay, so in order to use database, the first thing we do is to add the necessary dependencies. Let's quickly try that. So if we create a new, where is it? If we create a new project, Spring Boot project, let's call it GP test, maybe. Okay. So these four are the dependencies that we used so far: premarker, DevTools, web, and validation. And we will need two more. The first one is Spring Data JPA, and the second one is the driver for our database, which is the MySQL driver. So both of them are under SQL. Here is the Spring Data JPA, and MySQL is here. Notice that the one above is MS SQL. That's a Microsoft one. MySQL is the one we use. So if we create that project, this is what it looks like. Now, here we are not going to use the new project. I just want to show the process and the dependency to select. And since we already have a guestbook project here, all we need to do is copy over the two new dependencies. One is this JPA one. The other one is MySQL driver. Okay, so now we have the dependencies in our guestbook project. Is it still running? I think it stopped. Okay. So the next thing we do is to add some database configuration properties to the application.properties file. So let me copy over this to, you can delete this one. Let's delete here. We'll copy them here. Okay, so the first four properties, as we can see about database information, we need a host name, and I'm going to use my database on the CS3 server. So the host name is cs3.castella.edu, and the database name is my account name, which is CS3220STO31. And the username is this, and my password is ABCD. Okay, so this information, of course, is information that we would need no matter what database we access. Notice that this part is known as the URL of the data source, and as we can see, it's in a URL format. The host name, the path, protocol column // and the protocol here, instead of just HTTP or HTTPS, it actually says JDBC column MySQL. That's JDBC is a protocol, and the MySQL is called a sub-protocol. So together, it's basically saying we're using the MySQL variant of the JDBC protocol, and the host names, the path, and so on. So it's basically a standard URL format, including the information about the database host name and the database name, and then username, password. And here is the JDBC driver name, and for MySQL, it's com.mysql.cj.jdbc.driver. So these four properties are pretty standard database properties. Now, these two are properties that we would want to use during development. Show SQL will print out the SQL statements generated by the ORM library. It's useful for us to when we learn ORM, and it's also sometimes useful for debugging. Generate DDL, as we'll see in a moment, will automatically create or update the database tables based on the object relational mapping. This is very useful during development, but it is also quite dangerous because it doesn't care about the data that's already in the tables when it updates the table structure. So definitely remove these two properties or set them to false before your code goes into production. Okay, so the next step is to do the mapping part of object relational mapping, basically using some annotations to tell the ORM library how classes are mapped to tables. The first annotation we'll need is this entity. So the annotations will go into the model class. This first one is entity, and we import it. And what this annotation says is this guest book entry class should be mapped to database tables. Remember, there are lots of classes in an application. Most of the classes, like controller classes, have nothing to do with database. A class annotated with entity, which we would call an entity class, means the objects of this class will be stored in database. an entity class must have an ID field, and we will use the ID annotation to say which field is the ID field. By the way, notice that there are two ID we can import. We want the one that comes from Jakarta.persistence package. All of this annotation, mapping annotations comes from Jakarta persistence. Okay, so this one tells the ORM library which field is the ID field, and also most of the time we'll also use an annotation called generate value. And this annotation basically says we want the database to generate unique values for the ID field. And with this annotation, we can get rid of all the ID seed stuff, because database will generate new IDs for us now. Okay, so that's pretty much all the annotations we need for now. But in addition to the annotations, we need two more things. First, we would want to use a class type for ID instead of a primitive type like int. Remember, in Java, primitive types always have a default value. This means when we create a new guestbook entry object, the ID of the object will be 0 if we use this int type. And that sometimes can confuse the ORM library because it cannot tell whether 0 is an actual ID or not. If we use the class type integer, then when a new object is created, ID will be null. So in that case, there is no ambiguity whether the object is new or not. So it's generally a good idea to use class type instead of primitive type for IDs. And because we changed that, let's also change it here and here. Okay, yeah. And then there's one last thing we want to make sure. Entity class has a constructor that takes no argument. Basically, something like this. In this case, I guess we should also set the default date, the date. Yeah. So any entity class should have a constructor with no argument, because the ORM library will use this to create an empty object and then populate that object with data loaded from the database. So if we don't have that, we'll need to add that. Now, that's pretty much it for the mapping part. Now, with some relatively minor changes, we have converted our model class to a class that maps to a database table. So now this would be a good time to give it a try, and let me go to my database and let's get rid of all the tables in there. Okay, so no tables in my database, and and maybe we can keep this code for now. Let me run it and see if something will happen. Okay, so if we refresh here, we can see we now have two tables. The one is called guest underscore book underscore entry, and the other one is guest underscore book underscore entry underscore SEQ. These two tables are automatically created by JPA, and that's the part we mentioned earlier. When we set this property to true, then when the application is started, it will automatically create the table structure based on our object relational mapping here. So if we take a look at the table, we can see that this table has 4 fields: ID, date, message, and name, corresponds to the 4 fields here. And the additional guestbook entry sequence table, or SEQ table, is created by Hibernate and is used to generate unique values for ID. So we don't really need to care about this table. It's used by the underlying ORM library to generate IDs. But this table, as we can see, is created automatically based on our mapping here. Okay, so now we can proceed with the next step. Now we would want to add the database access code, and it's surprisingly simple to do. All we need to do is to create an interface that extends this CRUD repository interface. And this interface is a generic interface, meaning that we need to provide 2 types. The first is a type of the objects handled by this repository, and in other words, that's the entity class type. In our case, it will be guestbook entry. And the second type is a type of the ID field, and in our case, it's integer. So let's create that. I'm going to create an interface, and this interface is going to be in the package CL3220 repository. And yes, here. The name, I'll call it guestbook entry repository. And this one will extend CRUD repository, guestbook entry type, and integer type. So something like that. And import and import, and I think we need to make this a bin, if I remember correctly. Okay, so yeah, that should do it. So we don't even need to put any method in this interface, and the reason being, by the way, CRUD means create, read, update, and delete, and these are the common operations we use on a database. So as we'll see in a moment, the CRUD repository already provides the basic CRUD operations. So for now, we don't need to add anything here. because basic operations is provided by this one. So this is our data access code, and then now that we have that, we can get rid of our data store bins and stuff. And instead of injecting, so that's the next step, inject the repository into the controller. So instead of injecting data store, we are going to inject guest book entry repository. I'll call it repo. And guest book entry repository. Okay, so and then the rest is just changing the database access code. So previously we had data store get entries. Now here we will need to call repo something to get all the data. So that's when we look at the API documentation of CRUD repository. So notice that this one provides a number of methods for us. There's count, there's delete all, exist by ID, find all. So this is what we want. Okay. And then later we can do find ID and save. So we'll say repo find all. This will give us all the entries. And add this part don't need to change, and this part is add entry. So instead of saying get entry add, we'll say repo dot save. So it's this one. And here edit will get an entry. So here we'll say repo.get, not get, find by ID. And then here again we'll say repo find by ID. And the error is type mismatch, cannot convert from optional to guestbook entry. The reason is find by ID will return a optional object, which is a Java JDK 8 thing, basically saying something is either a non-null value or a null value. So the way to use this is to say find by ID else, meaning that if this thing doesn't have a value, then we'll use null instead. So that's pretty much it, I think. There any more I need to change? There's okay, we get rid of this. Okay, I think that should do it. So anything else? Okay, let's run this. Hopefully it will work. Okay, so we go back to guestbook, and there's nothing, and nothing because we don't have anything in here yet. And notice that here, because we have set show SQL to true, this one actually shows up the SQL statement generated by the ORM library Hibernate. And this select statement is generated by repo find all. But when we find all, the underlying ORM library will generate a select statement and get the entries from the database, which currently doesn't have any. Okay, so let's add something then. Let's say John says hello, and now it shows up here. Again, we can see the generated code. It generates actually a few statements. It does a select next value from the sequence, and then did an update, and then an insert, and another select to show the entry in the table. And if we look at our database, we can see John is here. And let's try Tom says hi, and let's add it, change John to Jack. So it's not changing John to Jack. Why it's not changing John to Jack? Let's see the edit part. So we get the new entry, we find the old entry, we set the name, set the message. Oh, we forget to save it. So after changing the old entry, we'll need to do a repo save and to save that back to the database. Okay, so refresh and edit and change it to Jack. And now it changed to Jack. So awesome. Let me stop this and go back here. Okay, so now our guestbook example uses a database for data storage. Let's take a step back and look at the big picture. The two things that make this possible are JPA and Spring Data. JPA gives us the annotations to map classes to tables, and the Spring Data automatically generates data access code like find all, save, and so on. And because our code uses the MVC architecture, it takes minimal changes to go from storing data in memory to storing data in a database. In particular, the model class is pretty much the same as before, with the addition of some annotations. The view templates are exactly the same as before. And in controllers, we only need to change the data access code. So in other words, everything we learned so far, everything we learned before still applies. So now the code is working and we know the basics. Let's explain a few more things. First, why it's called repository. The term comes from a design pattern called the repository pattern. The idea is to create a layer between application code and data storage. This layer allows application code load and save objects as if they are stored as a collection of objects, or aka a repository of objects. As we can see here, the idea of repository is basically the same idea as ORM. The difference is really that the repository pattern simply describes what it should be like. It's basically said the repository layer should make it like a customer objects. We have a collection of customer objects. Saving a customer object is like putting the customer object in this repository, and somehow this layer will translate that into saving it into the database table. The repository pattern describes how it should be like, and ORM is a technology that makes this implementation, I wouldn't say possible, but a lot easier. Even without ORM, you can create something that behaves like this, but ORM definitely makes implementation a whole lot easier. Okay, so another subject we need to know a little bit more is Spring Data, which, as we just saw, is the part that automatically creates repository code for us. So this is the Spring Data website. And as we can see here, Spring Data is one of the projects under the Spring umbrella, like Spring Boot, Spring Framework, and a bunch of other projects. Spring Data supports a whole bunch of data storage and data access technologies through Spring Data JDBC and Spring Data JPA. It supports basically all relational database systems, and it also supports all kinds of the so-called NoSQL databases like Redis, MongoDB, Cassandra, Solr, and Elasticsearch, and some of the ones I don't even know. So by and large, we don't have to know everything about Spring Data, but for our purpose, we need to know how to implement operations that are not provided by CRUD repository. So we've seen the API of CRUD repository, and it provides some commonly used operations like delete, find all, find by ID, and save, which is great. But what if we need more? For example, let's say we want to search guestbook entries by the username, and CRUD repository, of course, doesn't know the properties of the object. It doesn't know we're using guestbook entry, which has a name property, so there's no such method here that we can use, so we'll need to create our own. The question is, how do we create our own? There are a number of ways. In this lecture, we will introduce two ways to extend the CRUD repository. First is query generation from repository method names, and second is user-defined query using the query annotation. There are additional ways if we need to create more sophisticated queries or data access operations. We won't cover those in this class, but if in the future you work on projects that requires creating more complex queries or operations, you can always look up the documentation and find out, the ways how to do it. But now let's look at how we can do it first with query based on method name, which is kind of an interesting way to do things. So let's say we want to find guestbook entries left by users with a certain name. And so what we do is we will go into the repository and we will add a method here. So we will say guestbook entry and find by name, and we'll give it a name. And that's it. So notice that this is an interface. So we add a method and we don't need to actually implement this method. It's an interface. We cannot implement this method anyway. So just, give it a name and that's it. So does it work? We'll find out. So here, let me again run this first. So here we have two entries by Jack and Tom. And now suppose we change this. Instead of saying repo find all, we'll say repo find by name Tom. So find by name is a method we just added here, and we'll call it with find by name Tom. And if we refresh it here, it indeed returns only the entries that were left by Tom. So it worked. And this this is really kind of cool. It almost looks like magic, right? We don't even need to implement anything, and somehow the framework figures out the query just by looking at the name. And it turns out that it's not that complicated. What Spring Data does is it looks for special method names in this form, find something by some condition. The something between find and by is optional. So in our case, we don't have anything between find and by, and that's perfectly fine. And find something by together, this part is referred to as the subject, and the condition part is called the predicate. We can see the documentation what can be in subject and what can be in predicate. So these are the things that can be in subject. We can see that in addition to say find by, we can also say read by, get by, query by, search by, stream by. So we can use these forms to construct the method name. And we can also say exist by, or count by, or delete by, remove by. And then between something and by, we can use three keywords in between. We can say first a number, or top a number. These two are used to get like top and results. And we can also say distinct, for example, find distinct, by name, and this will remove duplicates. So these are things that we can put in the subject part of the method name. And then for predicate, we can, of course, use a property name, and we can then combine multiple property names using and or, and we can specify conditions like after, before, containing, between, it's empty, less than, nothing, so on and so forth. So it's I guess easier to kind of look at this by seeing some examples. We saw find by name, and here is find by name and message. So it will look for entries that matches this name and message matches this message. And then we can say find name ignore case, where it will ignore case when look for names. If you look at the documentation, there are even more examples. Find distinct by last name, find by last name and first name, find by age less than equal, and so on and so forth. So basically, by combining these properties and keywords, and we can create method names, and the framework or string data will generate queries based on these method names, which is kind of cool. But okay, so letting Spring Data generate queries from method names is neat. But for a complex query, the method name can get pretty long and awkward. In those cases, we can create the query directly and attach it to a method using the query annotation. So let's do an example. Suppose we want to look for entries that were added since a certain date. So I'm going to create a method, and this one will look for entries that were added since a certain date. And since we are going to specify our own query, the name no longer, the method name doesn't really matter. So I'm going to call it get entries since, and I'm going to give it a date, and this time we'll specify the query ourselves, and the query will say select E from guest book entry E, where E.date is greater than this date. Okay, so so this question mark 1 basically says take the first argument of this method. So whatever passed to this method will be placed here to complete the query. And yeah, let's run this and see if it works. Okay, so here instead of find by name, I'm going to say get entries get entries things. I need to give it a date. How do I do a date? Okay, so I'll say local date now, and then okay, we can say minus minus days. Let's say we minus 7 days. So this one should presumably give us only the entries left in the last 7 days. Now here I have two entries, both added today, but we can change this one. Instead of November, let's change it to October. So yeah. So if our code works, then it should only show Tom, not Jack. Actually, let's change this one back first. So let's first refresh, and it shows both entries because they are both added today. And now let's change this one to October. And then if we refresh, so now it only shows Tom, which has the more recent date. So yeah, this is how it works. Now the main thing about this is this query, which is actually a JPQL query. Remember, JPA, the standard defines a few things. In addition to the annotations, it also defines a query language called JPQL, and by default, this query annotation assumes the query is in JPQL. If we want to use SQL query, we can actually do that. But then we'll need to add the native query is true attribute to it, and then we can use SQL instead. The syntax of JPQL is quite similar to SQL, plus we don't really need to write complex queries in this class, so I don't plan to get into the details of JPQL. The main thing I like to point out is that JPQL is an object-oriented query language that operates on classes and properties instead of tables and columns. In this example, notice that we are selecting from guestbook entry, and it's a class name, not a table name. The table name is guest underscore book underscore entry, but here our query here actually select from the class name. And what this query is saying is basically that we want to select all the objects from this class. E here represent an object, not a column like a SQL statement. If it's SQL, here select, after select we will specify the column names. But here it's representing an object, and we're saying we want to select those objects where the date property of that object is after a certain date. Excuse me. So that's about it for this lecture. By now we know how to do database access using Spring Data JPA, and we have also seen how to extend Spring Data repositories with our own queries. So we'll talk more about JPA annotations in the next lecture. Yeah, for this one, this is it. Thank you, and see you in the next video.